Welcome back to Science for Sleep, where we explore the deepest questions in science, consciousness, and reality itself in a calm and immersive way designed to help your body rest while your mind journeys into the unknown. If you enjoy drifting towards sleep while discovering the hidden structure of existence, consider subscribing and allow yourself to relax as we explore tonight's question together. Because tonight, we are asking something that may be the most unsettling question ever seriously considered by science. Are you living in reality, or inside a simulation? Not metaphorically, not philosophically, but literally, a constructed universe, generated, rendered, calculated, experienced from within. At first, this idea may sound like science fiction. But over the past century, discoveries in physics have quietly begun to reveal something strange about the nature of reality. Something unexpected, something precise. Because when scientists look deeper and deeper into the universe, reality begins to behave less like solid substance, and more like information. To understand why, we must begin with something simple. Your senses. Right now, you feel your body resting. You hear sounds around you. You see the world. It feels direct, immediate, real. But your brain is not actually experiencing the external world itself. It is experiencing electrical signals. Your eyes detect light. Your ears detect vibration. Your skin detects pressure. These signals travel into your brain, and your brain constructs an internal model, a simulation, not of imagination, but of interpretation. What you experience as reality is a representation generated inside your mind. This does not mean the external world does not exist, but it means your experience of it is constructed. This is not speculation. It is neuroscience. Your brain builds reality from information. Now expand this idea outward. What if the universe itself also builds reality from information? This question began to emerge as physicists explored the smallest scales of existence. At the level of atoms, then particles, then something even deeper, quantum fields. At these scales, reality stops behaving like solid objects. Particles do not exist in fixed locations. They exist as probabilities, possibilities. They only become definite when measured. Before measurement, their properties remain undefined. This is not because we lack knowledge. It is because reality itself lacks definite properties until interaction occurs. This is called quantum indeterminacy, and it suggests something profound. Reality is not fully determined until observed. Now pause, because this challenges your intuition. You expect objects to exist whether you look at them or not. But quantum experiments suggest something else. The famous double-slit experiment demonstrated this clearly. When particles pass through two openings, they behave like waves, existing in multiple paths simultaneously. But when observed, they behave like particles, choosing a single path. Observation changes reality. This does not mean human consciousness creates reality, but it means interaction does, measurement does, information does. Reality becomes definite through interaction. Now imagine what this implies. At its deepest level, the universe behaves less like a machine made of solid parts, and more like a system processing possibilities into definite outcomes. This begins to resemble computation. Not computation like your computer screen, but computation in principle. Information being processed, states being updated, possibilities becoming outcomes. Now we must move forward in time. To a physicist named John Archibald Wheeler, he proposed something radical. A phrase, simple, but powerful. It from bit. He suggested that physical reality arises from information, not the other way around. Matter emerges from information. Energy emerges from information. Space and time themselves emerge from information. The universe becomes a system built from bits, units of information, not fundamentally made of substance, but made of relationships. This idea was shocking. But over time, more discoveries began pointing in the same direction. Black hole physics revealed that information cannot be destroyed. Quantum mechanics revealed that particles behave like information states. Thermodynamics revealed deep connections between information and energy. Everywhere scientists looked, information appeared fundamental. Now let us move to something even more unsettling. The universe has limits. There is a maximum speed, the speed of light. Nothing travels faster. This speed limit is not arbitrary. It is built into the structure of reality itself. In computer simulations, information also has speed limits, processing limits, bandwidth limits, rendering limits. Some physicists began to wonder, could the speed of light represent a maximum information transfer rate? A kind of cosmic bandwidth limit? Not proof, but suggestive. Now consider space itself. If you zoom into space far enough, you do not find smooth continuity. You find discrete units. The Planck length, the smallest meaningful unit of distance. Below this scale, space loses ordinary meaning. Reality becomes pixelated. Not visually, but mathematically. Like resolution limits in a digital image. Time also has the smallest unit, the Planck time. Reality updates in increments, not continuous flow, but discrete steps. This begins to resemble frames in a simulation. Again, not proof, but a pattern. Now consider energy. Energy also appears in discrete units. Quanta. Reality behaves as if it has resolution, limits, granularity. These features are exactly what you would expect if reality were information-based. Now we must be careful. This does not prove the universe is a simulation, but it makes the idea scientifically discussable. Not fantasy, but hypothesis. Now we move to a philosopher named Nick Bostrom. In 2003, he published a paper that changed everything. He argued something simple. If intelligent civilizations continue advancing, they may eventually create simulated universes. Simulations containing conscious beings. This is possible. There could be many more simulated realities than base realities. And if there are many more simulations, statistically, it becomes more likely that you exist inside one. Not because someone proved it, but because of probability. Now pause. This does not mean you are in a simulation, but it means the idea cannot be dismissed easily. It becomes a legitimate question, not just philosophical, but scientific. Now we must ask something deeper. If reality were a simulation, would you be able to tell? Or would it feel exactly like this? And in the next part we will go deeper still, into the strange mathematical precision of the universe, into the theories suggesting space-time itself may be emergent, and into the quiet and unsettling clues that reality may be more constructed than it appears. For now, rest with this thought. Everything you experience is built from information, and somewhere, at the deepest level, reality may be processing itself into existence. And so we continue drifting deeper now into the structure beneath reality, into the quiet patterns that govern everything you have ever seen, touched, or experienced. Because if the universe were a simulation or even something simulation-like, we would expect it to follow rules. Precise rules. Consistent rules. Mathematical rules. And when scientists began carefully studying the universe, they discovered something astonishing. Reality is governed by mathematics with extraordinary precision. Not approximate. Not vague. Exact. The same equations that describe the motion of falling objects on Earth also describe the motion of planets, stars, and galaxies across billions of light years. The same mathematical relationships apply everywhere we look. This raises a quiet question. Why should reality obey mathematics at all? Mathematics is not made of matter. It does not exist physically. It exists as structure, as logic, as relationships, and yet the universe follows it perfectly. Some physicists have suggested something extraordinary, that mathematics does not merely describe reality, it is reality. This idea was explored deeply by physicist Max Tegmark. He proposed what is called the mathematical universe hypothesis. It suggests that the universe is not just governed by mathematical rules. It is itself a mathematical structure. Everything you see, everything you are, every atom, every star, every thought, exists as part of a vast mathematical system, not made of substance in the ordinary sense, but made of relationships, patterns, information. Now pause here, because if reality is fundamentally mathematical, then it begins to resemble something else. Code. Not necessarily code written by a programmer, but code in principle, a system defined by rules. Now let us explore something even stranger: the constants of nature. These are numbers that define how reality behaves. For example, the strength of gravity, the mass of particles, the speed of light. These constants appear precisely tuned. If they were slightly different, stars would not form, atoms would not form, life would not exist. Even small changes would create a universe incapable of supporting complexity. This is called fine-tuning. Scientists have debated this for decades. Some argue it is coincidence. Others argue it reflects deeper necessity. And some have suggested something else entirely. That fine-tuning resembles parameter selection, like values chosen to produce a specific outcome. Again, this does not prove simulation, but it raises questions. Now let us move deeper still. Because reality does not only follow mathematical rules, it also appears to limit complexity. Information density cannot increase indefinitely. There are limits to how much information can exist within a region of space. Black holes revealed this. Their information content depends on their surface area, not their volume. This is unexpected. It suggests reality may store information on boundaries, not interiors. This connects again to the holographic principle. The idea that three-dimensional reality may emerge from two-dimensional information, like a projection. Now imagine watching a hologram. It appears three-dimensional, but its information exists on a surface. In this analogy, you experience depth, but the information exists elsewhere. Now rest with that image, because some physicists believe space-time itself may work this way, that the universe you experience may emerge from information encoded on a distant boundary. Not an illusion, but an emergence. Now let us return to computation. Modern computers simulate worlds. Video games create landscapes, characters, physics, light, all governed by rules. As computing power increases, simulations become more realistic, more detailed, more immersive. Some scientists have asked a simple question: could computing power eventually simulate an entire universe? At first, this seems impossible. The universe is vast, containing billions of galaxies. But simulations do not need to compute everything at once. They compute what is observed, what is interacted with, what is necessary. This is called lazy rendering. Only the visible region requires detail. This resembles quantum mechanics, where properties remain undefined until measured, not because reality is fake, but because reality may be defined through interaction. Now again, we must be careful. This is analogy, not proof, but it is suggestive. Now let us explore consciousness, because simulation arguments often focus on observers. Your awareness, your experience. Right now you are aware, not just existing, but experiencing. Science can measure brain activity, but it cannot fully explain subjective experience. Why awareness exists at all. This is called the hard problem of consciousness. If reality were simulated, consciousness could exist as part of that simulation, or as something interacting with it. But science does not yet know. We only know that awareness exists, and that it experiences reality from within. Now imagine something profound. If you were inside a simulation, everything would feel normal, consistent, real. Because the simulation defines your reality, there would be no external reference. no outside comparison. You would experience what the system generates. And this brings us to something deeply important. Even if reality were simulated, your experiences would still be real to you. Your thoughts, your emotions, your existence would still matter, because experience itself is real. Now let us move towards something calming, because whether reality is simulated or not, it follows rules, stable rules, reliable rules, rules that allow stars to shine, planets to orbit, life to emerge. You exist within those rules. You are part of the system, not separate from it. Now in the next part we will go even deeper, into the search for glitches, into experiments designed to detect simulation limits, into whether reality shows signs of computation constraints, and into the quiet realization that regardless of the answer, your experience of existence remains extraordinary. For now, rest within reality, whatever its ultimate nature may be, because here, you are part of it. And so we continue, moving now into one of the most intriguing and unsettling directions this question has taken. Because once scientists and philosophers began seriously asking whether reality could be simulation-like in nature, a new question emerged naturally. If reality were a simulation, would there be glitches? Small imperfections, moments where the underlying structure reveals itself, moments where the illusion falters. To explore this, physicists did not search for visual glitches like in video games. They searched for limits, because every simulation must have limits. Limits of resolution, limits of precision, limits of processing, limits of information. And when scientists examined reality closely enough, they found something unexpected. Reality does appear to have resolution limits. Earlier we spoke of the Planck length, the smallest meaningful unit of distance, approximately 1.6 times 10 to the minus 35 meters. Below this scale, space no longer behaves like ordinary space. It cannot be divided meaningfully. It becomes undefined. This suggests that space may not be infinitely continuous, but discrete, like pixels. Not visible pixels, but fundamental units. Time also has a smallest unit, the Planck time, about 5.4 times 10 to the minus 44 seconds. Below this duration, time loses ordinary meaning. Reality does not update continuously. It updates in increments. This is not proof of simulation, but it is exactly what you would expect if reality had finite resolution. Now let us move deeper still. Physicists have also discovered limits to information density. There is a maximum amount of information that can exist within a given region of space. This is called the Bekenstein bound. It suggests that reality has a maximum storage capacity, not infinite detail, finite detail. This again resembles computation, where memory is limited. Now imagine something else. Quantum randomness. At the smallest scales, events occur unpredictably. Particles appear, disappear, change state, not randomly in the ordinary sense, but probabilistically. Their exact behavior cannot be predicted, only the probability of outcomes. Some physicists have suggested that this randomness may reflect underlying processes, not true randomness, but unpredictability from within the system, like characters inside a simulation unable to predict the system generating their world. Again, this is not proof, but it is suggestive. Now we move to experiments. Scientists have attempted to test whether space-time shows signs of pixelation. One such effort was the holometer experiment, designed to detect whether space-time itself has fundamental resolution limits. The results did not find evidence of pixelation at the scales tested, but the search continues. Because if reality is information-based, it must have structure, and structure leaves traces. Now let us explore something deeply philosophical. If reality were simulated, would it make a difference to your experience? Right now, you feel your body resting. You feel your breathing. You hear sounds. You think thoughts. These experiences are real to you. regardless of their ultimate origin. Pain feels real, joy feels real, love feels real, meaning feels real. Simulation does not erase experience, it defines its framework. Now imagine a dream. When you dream, the world feels real, until you wake. But while inside the dream, it is reality. Simulation arguments suggest something similar. Not that reality is false, but that it may be generated. Now let us move towards something deeper. Some physicists believe that space-time itself may emerge from quantum information, not fundamental, but constructed from entanglement patterns. This means that space exists because information connects regions together. Without those connections, space would not exist. This suggests that reality may not be made of objects in space, but of relationships that create space. Now pause, because this reverses intuition. Space does not contain things. Things create space. Information creates geometry. Reality emerges from structure. Now let us address something important. There is currently no experimental proof that reality is a simulation. It remains a hypothesis, a philosophical and scientific possibility, not an established fact. But exploring it has revealed something profound. That information plays a central role in reality. That the universe behaves like a system governed by rules. That existence has structure. That consciousness experiences that structure. And in the next and final part, we will bring this journey to a calm and meaningful conclusion, not by proving or disproving simulation, but by understanding what this question reveals about existence itself, and why, simulated or not, your presence here remains something extraordinary. And so we continue, now moving gently toward the quiet center of this question, not toward a final answer, but toward understanding. Because after all the physics, all the mathematics, all the theories and possibilities, one truth remains constant. You are here. You are aware. You are experiencing. And whether reality is ultimately made of particles, or information, or something even deeper, your experience unfolds from within it. Now let us return to the question one final time. Are we living in a cosmic simulation? Based on everything science knows today, the honest answer is simple. We do not know. There is no experimental proof that reality is a simulation. There is no confirmed signal from beyond. No detectable edge where computation stops. No observable creator outside the system. But there is also no law of physics that completely forbids the possibility. The simulation hypothesis exists at the boundary between physics and philosophy. Not proven, not disproven, but meaningful, because of what it reveals about reality itself. It reveals that reality behaves like information. It reveals that the universe follows precise mathematical rules. It reveals that existence has structure, consistency, continuity, and it reveals something even more profound, that your experience of reality emerges from within a system far larger than yourself. Now let us consider something calming. If reality were a simulation, you would still feel what you feel. You would still think what you think. You would still matter to yourself and to others within this reality. Meaning does not disappear simply because reality has deeper layers. A character inside a story still experiences their world. Their choices still define their path. Their awareness still exists within their framework. And you exist within yours. Now let us go deeper still. Because modern physics increasingly suggests something remarkable. That reality is not made of solid things, but of relationships, connections, information. Matter becomes stable patterns. Energy becomes dynamic patterns. Space becomes geometric patterns. Time becomes sequential patterns. Reality becomes a process, not a static object, but an unfolding. You are part of that unfolding, not separate from it, not observing it from outside, but existing within it. Now imagine the universe from the very beginning, from the first moments after the Big Bang. Energy expanding, cooling, forming particles, forming atoms, forming stars, forming galaxies, forming planets, forming life, forming minds, forming awareness. For billions of years, the universe evolved toward increasing complexity, toward increasing structure, toward increasing awareness, until eventually, it produced you, a being capable of asking questions about the nature of reality itself. This alone is extraordinary, simulation or not. You are the universe becoming aware of itself. Now consider something even quieter. Every night when you dream, your brain creates worlds, places, people, experiences. They feel real while they happen. They have structure, rules, continuity. When you wake, you recognize them as internal simulations. But while inside, they are reality. This does not mean waking life is a dream, but it reveals something important. Reality as experienced is always generated through processes, through systems, through information. Now let us return to rest. Because regardless of whether reality is simulated, mathematical, informational, or something else entirely, it is stable. It is consistent. It allows your existence. It allows your awareness. It allows this moment. And perhaps that is what matters most. Not whether reality was created, but that it exists. Not whether it was programmed, but that it unfolds. Not whether it is simulated, but that it is experienced. Now imagine drifting outward, beyond your body, beyond your room, beyond your planet, beyond your star, beyond your galaxy, into the vast quiet structure of the cosmos. Billions of galaxies, billions of stars, all governed by the same underlying rules, all part of the same system, a system within which you exist, a system within which you are aware, a system within which you are asking these questions. Whether simulation or not, you are here. You are real within your experience. You are part of reality's unfolding story. And as you drift now towards sleep, let the question remain open, not as something that must be solved, but as something that can be wondered about. Because wonder itself is part of consciousness, part of existence, part of you. You do not need to know the ultimate answer tonight. Reality will continue. The universe will continue. And somewhere within it, so will awareness, so will experience, so will you. Thank you for exploring the grand design of the universe here on Science for Sleep. Rest now, and allow yourself to drift peacefully into the quiet mystery of existence. Good night.